Welcome. I'm Teresa Hauk, Executive Editor of the Journal from Rockwell Automation and our partner network magazine. Today I'm talking with Chris Hardawar, Vice President of Automation at Maplesoft. Thanks for joining me, Chris. It's always great to see you.
Thanks, Teresa. Thanks for having me. It's great to be here.
So we've seen Maplesoft at a number of Rockwell Automation events globally. There's a lot of interest in your company. So tell me about what your company does, and also what product are you showcasing at Automation Fair, and what does it do?
We're actually showcasing our simulation platform. It's called MapleSim, and MapleSim really allows you to create digital models of your machines and your mechanisms to test them in a safe virtual environment, and allows for virtual commissioning as well. And Maplesoft, we've been around for over 30 years, and we pioneered our technology around a highly sophisticated math engine. And that math engine is actually what makes MapleSim so special, because it's underneath the hood. It does all the equations and calculations for you and reproduces a real world simulation of how you would see your machine or your mechanisms behave, as if you were standing right next to it.
And a lot of times when I talk to manufacturers, they don't always understand why they should use virtual modeling. What are the reasons some companies go through the virtual modeling steps? How is it useful?
Well, I think the easiest way to answer that is the same reason for prototyping. So when you're creating a new design, a new machine, companies prototype a version first so that they can play with it, they can see how it behaves, they can understand the performance limits of it. And that physical machine, can have multiple engineers touch it all at once. But in the virtual world, you could do a lot of that and get a lot of the same kind of answers right there on your computer's desktop. Because of that math engine I talked about earlier, it allows real physics and real behavior, real math properties to be input into the model. And then the model can actually behave the same way as if it would behave in the real world. And then you could take it and connect it to the control code environment and do that virtual commissioning piece where the machine can be commissioned online, and then give you those results as if it was right next to you in the prototype stage, or when you get to the manufacturing stage, or even out in the real world. So I would say companies use it to test in a virtual environment the prototype and their design ideas, and improve performance of the machine itself.
Well, that sounds amazing. Do you have an example of a customer that uses MapleSim so that people can get kind of a picture of how it works?
I'm glad you asked that. So I sure do. The customer in this case that I'll talk about is a customer in injection molding, and they basically had a machine already at the customer's site, at their end customer site, that was underperforming. So when their end customer wanted to turn up the speed to meet the performance specs, the machine would vibrate. Actually, that mass on the end of the hydraulic cylinder started to vibrate, and they couldn't get the production numbers they wanted. They turned to Maplesoft, and our application engineering team helped them use MapleSim to create that virtual model, a very simplistic version, right? Because you could spend a lot of time in doing simulation, or you could spend very little. You get what you get out of what you put into it. And so a very simple model was made of the hydraulic circuit combined with the mechanical. And that's what also makes MapleSim special, is that you can connect different domains, so mechanical, hydraulics, electrical, all in one platform. They reproduced the issue they were seeing, and then their controls engineers were testing the control code against the virtual model at home in their pajamas, actually, and not being next to the machine on site. And they tested it. They came up with a new control strategy, and at the end of the day, they had minimal downtime on the physical machine. They updated the control code and were able to increase the performance of the machine by 25%. So that's 25% more product going through that machine, because they were able to tune and optimize the virtual model.
Wow, that's fascinating. I know there's a lot more to learn than we can talk about here. How can people find out more about modeling and MapleSim?
You can go to our website at www.maplesoft.com/MapleSim, or you can contact us directly at Maplesoft, or contact me directly. And you can find us at the show at Automation Fair. Say hi, drop by our booth or our virtual booth, depending on what that's going to look like, and ask us any question you want. We are happy to help.
And I've been at your booth. It is fascinating and it's fun to see how things really work. Well, thanks, Chris. This has been very useful information. I appreciate you talking with me.
Oh, I appreciate the questions and I appreciate this chat as well. So thank you for asking all the right things. I'm happy to chat.
And I'm Teresa Hauk with the Journal Magazine, and we'll talk again soon.